and show you how to deal with this unit circle. All right, so I left it completely blank. And I might have to, yeah, that's better. Sorry, I have to turn some lights off so you guys can see better. All right, so what I'm going to start with first are the coordinates. So um, all of these coordinates around, the easy ones to start with are the actual units. The reason it's called, did I record? Yeah, the reason it's called a unit circle, it's based off of one unit. So when you come from the center, which is 0, 0, out, we went out one unit, we didn't go up any. So each one of those are going to be one unit. So if we go from the center to the top, we didn't go out any, but we went up one. Same thing on the other side from the center to the left. We went negative 1 units, but we didn't go up any at all. And then on the bottom, we didn't go left or right any, but we went down one. All right. If you have any questions the whole time that I'm doing this, please let me know. This will take up a chunk of our time and then we'll work on the packet. And then, like I said, I would review this, but it's really, really simple. All right. So then the only quadrant you have to really remember is the first one. And then from there, it's just reflections. So the first quadrant, remember, it's always positive, positive. And if you want to put that in there, that's fine. I don't ever do that just because I know it. But if you need it, that's fine. So quadrant 1, your first coordinate is 3 square root of 2, 1/2. And those are based off like 30, 60, 90 triangles. So I could show you how to get it, but it's easier if you just go ahead and just memorize it, okay? And I think, like I said, I think Miss Burkhart is going to do that for you. The middle one is always easy because it's the same coordinate. Sorry, square root of 2 over 2. And that's for both of them. Okay, square root of 2 over 2. And then this top coordinate is this one reversed. So 1/2 and square root of 3 over 2. Now, all you're going to do is manipulate it. So they reflect each other. And I told you it's just reflections. So this one is on the top of this quadrant. It's going to be on the top of that one. But this quadrant is a negative positive quadrant. So again, it's going to look exactly the same, but we're putting it over here. And we're going to change it. Negative 1/2 square root of 3 over 2. The middle one is always square root of 2 over 2. And then whatever sign you're supposed to have. So the first one's supposed to be negative. And then same thing, we're going to look here. It's square root of 3 and 1/2, or it's the reverse of this. Square root of 3 over 2. That one's going to be negative and 1/2. Does anybody have any questions so far? All right, the bottom quadrant, I'm going to try to make this a little bit taller so we can see everything. I'm doing the best I can, y'all. The bottom quadrant, remember, is a negative quadrant. So all of your signs should be negative. The easiest one to start with is the middle one. Negative square root of 2 over 2, negative square root of 2 over 2. Again, they reflect each other. So square root of 3 over 2 and 1/2 is going to go right here. They reflect over the axis. Square root of 3 over 2 and 1/2. And remember, they're both negative. And then this one's going to be the reverse, or it's going to mirror this one. So it's negative 1/2 negative square root of 3 over 2. Again, everything is just a mirror. This quadrant is a positive negative. Again, the middle one is the easy one, square root of 2 over 2. And the second one's going to be negative. You can either mirror these or you can mirror these. It doesn't matter. They're all the same. So if we have negative 1/2 negative square root 3 over 2, it's going to go right here, but you need to have it with these signs right here. So positive 1/2 negative square root of 3 over 2. And then this one is just the opposite. Square root of 3 over 2 and negative 1/2. So those are your coordinates. And again, if you can remember the first set, then everything else is just based off mirroring or reflecting it over. All right. Your degree should be fairly easy. This degree is either 0 or it becomes a full circle 360. I'm going to pull it back down so you guys can see a little better. I apologize. I'm not trying to make you like sick or anything, just trying to get everything on there without it being so tiny you can't see. All right. So then you have a main diagonal, and being at home, I don't really have anything to graph it. So like this one, the ones that are not cut through are actually the ones that I'm looking at, okay? Those are going to be your 45s. So what you have is 30, 45, that's a 45, 60, and you guys know that this is 90 degrees. So this is a right angle, it makes 90 degrees. All right. So each middle, so 2 square root of 2 is 45 degrees. So this is how I do it. I'm going to turn my phone on airplane mode so it don't have a million things going into it. Give me just a second to clear everything out. I didn't bring a calculator home. So I'll use the one on my phone. And like I said, I just put it in airplane mode so nothing will come through. Trying to make it dark for you guys to see. All right, so 30, 45, 60, 90. So then each main diagonal is 45, or each middle. So I do 90 plus 45 gives me 135. So this one, anything 2 square root 2, 2 square root of 2 is going to be 45. If I add 45 again, you'll see that I get the 180, and you know that half a circle is 180. If I add 45 again, I get 225, and that matches up with the 2 square root of 2's. Add 45 again, I get 270. You should know that this one is 270. And then add 45 again, and I get 315. Everything else is based off 30s. So 0, 30, 60, 90. 90 plus 30 is 120, just to show you. The next one, add 30 again, we get 150. Add 30 again, we're back at the 180. Add 30 again, we're at 210. Add 30 again, we're at 240. Add 30 again, we're at the 270. That's at the bottom. Add 30 again, we're at 300. Add 30 again, we're at 330. Add 30 again, we're at 360. So that's how easy those are. Okay, so again, 30s, 60s, and 45s. And then I haven't talked about this yet. I think it may be a Math 2 concept, but if it's not, it's okay. We're going to change degrees to radians. So it's easier for me to change the degrees to radians. That's what the rest of these are. So to do that, you're going to do your degree times pi over 180. So basically what you're doing is you're putting that degree that I just showed you and dividing it by 180 and then throwing a pi beside it. So on the first one, it's either going to be 0 pi or 2 pi. 360 is 2 pi. Let me show you why that's the case. 360 divided by 180 is 2, and we just throw a pi beside it. That's it. So if we want to do the 30, we do 30 divided by 180, but I want it in fraction form. So I get 1/6. So this one is pi over 6. That's it. 45 over 180, math, enter, is 1 over 4. So that would be pi over 4. 60 divided by 180 is 1/3. So this one would be pi over 3. That's literally all you do. This is the whole unit circle. 90 over 180 is 0.5 or 1/2. You guys know that. So this one would be pi over 2. 120 over 180 is 2 over 3. So this would be 2 pi over 3. 135 over 180 is 3/4. So this one would be 3 pi over 4. 150 divided by 180 is 5/6. So 5 pi over 6. And again, 180 divided by 180 is 1. So this one is 1 pi, or you can just put pi. It doesn't matter. Okay. Moving down to the next quadrant. 210 over 180. Math, enter. Gives us 7 over 6. So this one is 7 pi over 6. 225 divided by 180 gives us 5 over 4. So 5 pi over 4. 240 divided by 180 gives us 4/3. So 4 pi over 3. On the bottom, 270 divided by 180 gives us 3/2 or 3 pi over 2. The last quadrant, 300 divided by 180, math, enter, is 5/3. So 5 pi over 3. 315 divided by 180 is 7/4. So 7 pi over 4. And then 330 divided by 180 is 11 pi over 6. So any questions about unit circle? Just like I said, if you can memorize, you know that these are units. So the main diagonal are units. And then for your first quadrant, you just manipulate it to me the signs on the second quadrant, third quadrant, and fourth quadrant. And then for your degrees, 30, 45, 60, same thing, add 30, add 45, add 60 to 90. Get to 180, add 30, 45, 60. Get to 270, add 30, 45, and 60, okay? As far as your radians, you do your degree divided by 180 and then throw a pi next to it, okay? So any questions on unit circle? Is everybody okay with that? All right. We're going to go to our packet, and we're going to start with the 2013 packet and hopefully finish it up. I don't know if we finished it or not. We're going to check it out and see what we got. All right. We did 1, 2, 3. We have not done number 4. We're going to hang on to number 4 for a minute. Look at number 5. Number 5, I did with graph paper, and I'm completely unorganized at my house. So give me just a second. I have the graph paper. Remember, you're going to get graph paper that has nothing on it. Okay. It's just going to be bricks. So just blocks like this. All right. So which equation of a parabola that has a directrix of -5 and a focus at 2, -1. So we got to remember what each of those were. So remember, the directrix was the line and the focus was the little point inside the parabola. So I'm going to make my own coordinate plane, and it said your directrix was at y equals -5. 1, 2, 3, 4, 5. Your focus was at 2, -1. And then what do we know about this? What's this help us do? I don't know if I have myself turned down. Hold on. Hopefully y'all are talking. Tell me what this does. Why do we need the focus and the directrix? Y'all are all remote, so y'all got to tell me. There's nobody in class answering. Get out.
Points up.
Okay. What else? We know that it points up. They're all positive, so that's good. Somebody chatted. Oh, you're fine, Jordan. Don't worry about it. What else do we know? Remember that the parabola is in between those two lines, right? What specifically is in between those? Not two lines, but the line and the focus, or the directrix and the focus. What specifically is between those two things?
Vertex.
The vertex. So remember, the vertex is halfway between. And what is that coordinate? Come on, guys. What's the coordinate?
2, -3.
Thank you. So then when we put that in our equation, remember the x coordinate, we're going to change the sign of, and the y coordinate's going to stay the same. So that's what we're going to look at first and ignore the 1/8 and 1/2. So what we're looking for inside the parentheses is an x minus 2 squared, and outside a -3. Do we have one of those without having to worry about the beginning?
C.
So that's all you have to do. Okay. There's not really anything you can do other than that. Like on Desmos, there's not really much you can do on that. You could plot it instead of using your graph paper. That's fine. But you could put your answers in and see the one that goes through there. It doesn't matter. That will just take a long time. All you needed was the vertex, and know that you just switch those signs on the x coordinate. Okay. We're going to hold off on number 4. It's not that it's hard. It's just weird. We did 5. All right, look at number 7. Number 7 was one of those things that we just did not get to, and typically I don't get to it anyway. But do you guys remember the arc length formula? Because we're going to come back to that soon. Do y'all remember arc length? This has nothing to do with it. We're not finding the arc length on this at all, but does anybody remember the arc length formula?
Angle times 2.
No. Remember, arc length is just finding this little bitty section right here. So just, you're going to have to know both of these formulas. This formula will come up in just a minute. Remember, it was degree over 180. I'm sorry, degree over 360 equals your arc length over pi times your diameter. You could do pi r squared as well. It's a piece of the circumference. So it's a proportion of the circumference. That's why we do pi times diameter. This one, because we're doing area, we're going to do area of a sector. Now let me show you the difference in these formulas. Area of a sector looks exactly the same. Degree over 360 equals area of the sector over. But since area is part, the sector is part of the area, that's where this formula changes. Is down here, it becomes the area of the circle formula. So this is circumference because it's a part of the outside, and circumference is the outside of the circle. This one is part of the area of the circle, so we use the area formula. Okay, so that's the only difference in the two formulas, is which you use. Okay, so then what it wants to know is how to figure out this. So a sector is like a slice of pizza. So what we want to do is take this pizza, and this is a thick crust pizza, if you want to imagine it like that. So we want to take this slice of pizza and only eat the inside and leave the thick crust. We don't want the, or we want the thick crust, whatever. So we got to cut out this. All right, so here's what we're going to do. You're going to do area of the big minus area of the little sector. Okay, so here's what I mean by that. The big one is the huge slice right here. So that's the big one. The little one is this little tiny, would be the toppings of the pizza. Okay, so we're going to start with the big one. They both have the same angle, so this formula is going to look exactly the same. The difference is going to be the radius. The small one has a radius of 2 and the big one has a radius of 6. So we're going to start with the big one. And we're going to have our degree, which is 30 over 360. We don't know the area of the sector. The big radius is 6. And I'm going to leave it like this. I like to keep it in terms of pi. So I'm going to do it in terms of pi. We're going to cross multiply. We get 360x equals, and we're going to do 30 times 36. I don't have my calculator out. I'm sorry, y'all. 36 comes from 6 squared. So 30 times 36 is 1080 pi. And then I'm going to divide by 360. So 1080 divided by 360 is 3 pi. And again, I like to leave it in terms of pi because otherwise you get a nasty decimal. And eventually we're going to have that decimal, but it's going to be the perfect decimal. Okay. So now we need to do the little one. Still the same, 30 over 360. Remember, the only difference is that we have a radius of 2 on the little tiny one. We're going to cross multiply. We get 360x equals 30 times 4 is 120 pi. We're going to divide by 360. 120 divided by 360 is not going to give us a whole number. It's going to give us 1/3. And then we want to do the big one minus the little one. And I'm going to put that straight into my calculator. So 3 pi minus, and I'm going to do 1/3 in parentheses, pi. And we get 8.377, which is approximately D 8.4. So it's kind of a lot of work, but it's not bad. Okay, so don't forget those two formulas. You do need to know both of those formulas. I think I've only seen one area of the sector on an exam, period. So just be ready for that. But I have seen arc length on all of them. So you definitely need to know arc length. All right, let's keep going. We did 8 and 9. We did not do 10. All right. So it says Fred drives an average of 15,000 miles per year and his car gets 20 miles per gallon of gasoline. The average cost of gasoline is $3.25 per gallon. He buys a new car. In his new car, he continues to average 15,000 miles per year and the average cost of gasoline remains the same. Approximately how many more miles per gallon does the new car get if Fred has a savings of $6.50 per year? So the first thing we need to figure out is how much he's spending per year. How do we do that with his old car? Nobody knows? How do we figure out how much he's spending? Come on, guys. He drives an average of...
Divide 15,000 by 20 and multiply it by 3.25.
Thank you. So we got to figure out miles per gallon and then multiply by the per gallon. So 15,000. We're going to divide it by 20 to see how many times he's actually filling up his car. That will give us 750. And then we're going to multiply by the cost, which is 325. And that's going to give us 2437.5, just so you don't have to do the math. All right. But he wants to save $6.50. So how much does he want to spend? How do I figure that out? Right now he's spending $2437.50. How do I figure out saving $6.50?
Subtract the 650.
Subtract $6.50. So he only wants to spend $1787.5. Sorry, y'all can't see my calculator. Is everybody good? All right, so let's think about how we got that formula. We did 15,000, because that's staying the same, divided by how many miles per gallon the car gets. The new car, we don't know. That's what we're trying to figure out. We multiplied that by 3.25 to get our total cost, but this time we want the cost to be 1787.5. How would I solve this formula? How would I solve it? Well, if I'm solving for X, what do I need to get rid of first? What's on the same side but not with it?
Divide 3.25.
I know y'all know how to do this. I just need you to talk to me. I know it's different. So 1787.5 divided by 3.25 is 550. So we get 550 equals 15,000 divided by X. You can cross multiply if you'd like put the 1 under here and cross multiply. But essentially what you're doing, just as a cheater method, is you're switching these two. So X equals 15,000 divided by 550. Which gives us 27.27. Now that answer is not on there. Why? What do they ask for?
How many more?
How many more miles does it get? So we had 20, so the old was 20. The new is 27.27. So how many more miles does it get?
$7.3.
Yeah. Any questions? So again, the ones that I left were a little bit longer. They're not necessarily hard. They're just longer. Okay, so 10, 11. We did 12 and 13. And we won't go over the 40 minutes, y'all. I won't make y'all do that. Okay. I hope y'all enjoy this little day you get, and then just study your tails off. All right, number 14, a shipping company. I don't know what's going on under here. Let me clean up a little bit, okay? All right. A shipping company is designing boxes to meet specific requirements. Each box must be completely closed, rectangular prism with no overlapping material. So it's a box. It's going to close up. The boxes must hold 24 cans in 2 layers of 12 each. So this is where it kind of tricks you up a little bit, because you automatically think like 12 and 12. And I get that, but a lot of times what we think is like 12 lengthwise rather than a different way, okay? But I'm going to explain which one you need to do. The cans are 3 inches in diameter and 5 inches in height. What is the smallest amount of cardboard needed to meet specifications? So smallest means you want to compact it. So if we think about 12 cans, I'm doing 12 because there's 2 layers. What shape do I need to try to put it in to make it the most compact? Like how would I set the cans up to be the most compact, like squished together?
6 and 2.
Okay, well 6 and 2 makes them really long, right? Is there any way I can squish them together more?
4 and 3.
Yes, so I want to squish them into more of a square shape. So anytime it says smallest, you want to do that square shape. So you said 4 and 3. So if I'm looking into the box, and y'all, I have to do this because I'm a visual person, so I hope some of you are too, and it helps you. This is what I'm going to see on top of the box. And I didn't draw that very well, but it's okay. You get the idea. When I'm looking down into the box, this is what I'm seeing. If I were looking in the side of the box, what I'm going to see, and I'll show you in just a minute. One side I'm going to have 4 cans, 2 high. And one side I'm going to have, sorry, crude drawing, not the art teacher, 3 cans, 2 high. Does that make sense? Does everybody see that? All right, so then it gives me my dimensions so that I can find what I need. What do I need? I need my surface area. It's just like I don't know if we did the tennis ball or not. I think we did the other day. It's what you want on the outside. So it's not the volume. We don't care about the inside. We care about the cardboard on the outside. So we're actually doing surface area. Okay. So we're going to talk about the top, the bottom, the left, the right, and the front and the back. So this would be the top, and it's going to be the same as the bottom. So we're going to multiply that by 2. So here's how we find the area. What did it tell you about the cans? They were what?
3 inches in diameter.
So what is this length right here?
9.
Perfect. Same thing on this side. What is this length going to be?
15.
Look at it one more time. 3 times 4 is?
20.
Slow down. 3 times 4 is 3 diameter, 4 cans.
12. I was looking at the 5.
It's okay. I know what you're doing. We're okay. All right. So now we're going to talk about the top and the bottom. How do I find the area of the top and the bottom? I'm going to go down into this problem because we've already done it and it doesn't matter. I'm going to multiply by 12 and 9. But remember that there is a top and a bottom. So I'm going to do it twice. Okay. There's a top and a bottom. Then we have the front of the box. The front of the box. So again, same thing. These are diameters. Doesn't matter where the can's at. They're still going to be the same width or the same diameter. So this is going to be your 12. But what is the height of the cans? Each can was how much?
5.
5, and there are 2 of them. So this is going to be 10. So this is the front of the box. We're going to add it in, 12 times 10. But there's also a back of the box. We're going to multiply it by 2. Then there's a left and a right. Here's the left. Again, same thing, the diameter of the cans. This was our 9. Our height is still going to be the same at 10 because it's 2 cans high. So we're going to add 10 times 9, and there's a left and a right. Put all that in your calculator, and I'm going to do it for you so you can see it. 12 times 9 times 2 plus 12 times 10 times 2 plus 10 times 9. I did that right? Times 2 is 636. So our answer is C. Okay, so not a hard problem. The hard part is this right here, compact. If you try to do it like you said the first time and you try to do like 6 and 2 or whatever lengthwise, it's going to give you one of these numbers, but it's not going to be the smallest amount of cardboard. Okay. We have about 5.5 minutes left. I'm going to try to see what we got in here. All right. So William put the tip of his pencil on the outer edge of the graph of the unit circle at the point 0, -1. He moved his pencil tip through the angle of 4 pi over 3 radians in the counterclockwise direction. At what angle of the unit circle did he stop on? Now I'm going to tell you, I don't need the unit circle for this at all. Where he started was down here. It said he moved his pencil tip through an angle of 4 pi over 3. I can't do 4 pi over 3, so I can change it back to degrees. So the way you change it back is you do the opposite of how you put it in. Wherever the pi is, you're going to put it on the opposite. So that pi is on top. We're going to put a pi on the bottom and 180. So remember when we were doing our unit circle, it was pi over 180 because we were going from degrees to radians. To go from radians to degrees, we do it this way because that way our pi's will cancel out. And then just in your calculator, we should have turned the lock screen off. 4 times 180 divided by 3 is 240 degrees. So what it says is it went 240 degrees this way. So this is 180. So this was 180. Here's how I did it. 240 minus 180 gives me 60 more degrees. So plus 60. What is this actual degree up here? It's not 180, but it's what?
$90.
90. Plus 60 is what?
$150.
So we're actually at 150 degrees. Now we have to turn it back into radians. How do we turn it back into radians? If to turn it into degrees, we do 180 over pi. How do we turn it into radians? Remember, it's the opposite. We want the pi on top and then the 180. So all you're really doing, dividing 150 by 180, math, enter, and you get 5 over 6, and you have that pi. So your answer would be B. Okay, so you don't need the unit circle really memorized to be able to do that. You just need to know how to convert from degrees to radians. All right, again, 2.5 minutes. We'll have plenty of time to do this one. Actually, let's hold off on this one. You're not gonna know how to do that right now, but we'll get that. That's again a math 1 question. That's not a math 3. Just to review it. This one's easy. We'll knock this one out real fast. 22. All right, so it says the sum of the series can be calculated using this formula. You just have to know what these are. So A1 is your initial. Anything A1 is always your initial. R is your rate or your multiplier. You already know what that is. And N is the number of times. We've done this multiple times. You just don't know that we have, okay? So what's your very first number in the sequence? Quickly, I have 1.5 minutes. First number in this sequence.
8.
8. Your rate is whatever your multiplier is. Okay, so -1/7. I'm gonna put it in parentheses. How many times are you doing it? 2,500 to the 2,500. On the bottom, 1 minus your rate was -1/7. Put this in your calculator. Again, I have less than a minute. I'm gonna try to get this in really fast. I'm gonna do alpha y equals 8 parenthesis 1 minus, there's another fraction, -1/7. Oh, delete that out. To the 2,500. I may have to go back and put parentheses in here. I would feel more comfortable if I did. I'm trying, y'all, sorry. And then 2,500 should have a parenthesis outside it. On the bottom, 1 minus parentheses -1/7. And we get 7. So your answer should be B. Okay. Any questions? It's going to kick me out. If you guys need anything, just email me.